Hey everyone, and welcome. Today we're going to talk about something we've all experienced, high school math. We're going to look at a totally new way of thinking about it, one that's designed to flip it from just memorizing stuff into a tool for real innovation. So let's get into it.
Ah, yes, the classic question. You're sitting in class, staring at a board full of equations, and you think, seriously, when am I ever going to use this in my life? It's a totally fair question. And for way too long, there hasn't been a good answer. But what if we could change that? What if the point wasn't just to find X, but to actually understand the power behind it?
So, to answer that big question, we have to start by rethinking the entire reason we teach math in the first place. This first part is all about making a huge shift, moving from just learning what the formulas are to understanding why they work.
This comparison really lays it all out. On the left, you've got the old school way, memorizing steps, solving abstract problems, just finding the answer. But on the right, you have the future-ready model. Here, it's all about critical thinking, using math in the real world to get a deep understanding, and then, and this is the cool part, using that understanding to actually drive innovation. It's a completely different game.
Okay, so what does this new vision actually look like when you put it into practice? In this section, we're going to explore a curriculum that's built from the ground up to create this deeper, more intuitive connection with math, making it something that's truly relevant for the future. The whole philosophy really hinges on this one core idea: conceptual understanding. Think about it like this. It's the difference between just following a recipe and actually understanding how the ingredients work together. When you get the why, you're not stuck if you run into a problem you've never seen before. You can actually think your way through it.
So where does this new philosophy lead? Well, to some pretty big goals. The idea isn't just to teach math, it's to spark innovation. It's not just about problems on a page, but about applying these skills to fields like STEM and finance, by really mastering advanced stuff. This is way beyond just passing the next test. It's about building a powerful analytical toolkit you can use for life.
All right, let's make this real. Let's see how this approach actually works in a lesson. We're going to peek inside a module on advanced equation solving and see this philosophy in action. Now here is the crucial mind shift. In this new approach, solving equations is no longer just a treasure hunt for the value of X. The real goal is to see the equation as a story about relationships, about how different pieces influence each other and work together inside a system. And we see this play out in three key areas. First, you have quadratic equations. We stop seeing them as just abstract parabolas and start seeing them as the tools we use to model the beautiful curves all around us, like the arc of a thrown football. Then, with simultaneous equations, we can find that single critical point where different systems, like supply and demand, meet. And finally, literal equations give us the power to rearrange any formula to see it from a brand new angle.
And now we get to come full circle, right back to that classic question. When will I ever use this? This is where we get the answer, by connecting these ideas to real, important jobs.
For instance, think about an economist. They use systems of simultaneous equations to map out supply and demand. And that solution, the point where the lines cross, that isn't just a number. That's the equilibrium price, the sweet spot where the entire market finds its balance. That's powerful. Or how about a physicist in a lab? They use literal equations all the time. Being able to take a fundamental law of the universe, like the formula for kinetic energy, and just effortlessly rearrange it to solve for mass or for velocity, that is an absolutely essential skill. It's how they design experiments and discover new things. This is math driving science.
So how do we get students to this level? You can't just wish for it. It takes a really powerful support system, the right tools and the right structure to build these capable thinkers and innovators of tomorrow.
Yeah, this isn't about just throwing textbooks at students. It's a whole ecosystem for learning. It all starts with mastery-based learning, so you don't move on until a concept is totally solid. Then you build on that with cool, interactive tools, group projects, and practice modules to get fluent. And if you get stuck, there are video solutions from all kinds of different tutors, so you can always find an explanation that just clicks. And it all comes back to this one mission. I mean, it's not about creating human calculators, right? The ultimate objective is to give learners the skills they need to become highly capable, flexible, and creative mathematical thinkers. The kind of thinkers who can go out and solve the world's most complex problems. Which really leaves us with one final, powerful thing to think about. If we actually do this, If we move past memorization and empower students with this kind of deep, conceptual understanding of math, what kinds of problems could they solve? What amazing breakthroughs are waiting for us just on the other side of a better equation?